So far, we have looked at quadratics written in standard form, y equals ax squared plus bx plus c, as well as quadratics written in vertex form, the y equals a parentheses x minus h squared plus k. What we're going to look at today is if you're given it in standard form, how can you rewrite it to vertex form, which reveals your vertex and is a skill that will be necessary in further math classes and other chapters. So these are the steps for rewriting an equation into vertex form. I'm going to make sure if you don't get all of these copied down, you can pause the video so that you can get them written down. And then we will work through them on two examples. But if we're given the equation and y equals ax squared plus bx plus c, the first thing that you're going to do is you're going to look at the first two terms, and we're going to ignore the c for a second, and whatever your a is, we're going to factor that out. So we're going to put that out in front of the parentheses, and we're going to divide the ax squared by the a, and the bx by the a. And again, that will make more sense once we get to an example. Once we have it rewritten, we're going to take half of the new b, half of that new number that's in front of the x, and we're going to square it. And just so we can refer to it later, we're going to call this n. I need to add the n inside the parentheses. And then outside the parentheses, we're going to subtract whatever a times n is. And then we can rewrite it as a perfect square. And in order to rewrite it as a perfect square, since the first term will be x squared, we're going to take the square root of x squared, which is just going to be an x. We're going to take the sign from the middle of what's in the parentheses. And again, I'll show you how to do all of this. And then whatever this n is, we're going to take the square root of it, put all of that in parentheses, and square it. So let's look at a few examples. All right, here we have our first example, and it's f of x, or y, equals 3x squared plus 18x minus 9. Now, the first step says we're going to look at these first two terms, and I'm going to factor out or divide them by this 3. So I'm going to rewrite f of x equals, and I'm going to move the 3 out in front of the parentheses. And when I divide 3x squared by the 3, it just leaves x squared. And that's always the goal, is to just get this to be an x squared by itself. Then I'm going to have plus, and 18 divided by 3 is going to be 6x. Now, because I know what I'm going to be doing in the next step, I'm going to leave some space and write the minus 9 behind the parentheses. So we're going to fill the space in here. This was step number 1. Step number 2 says to take half of b. Now, half of 6 is going to be 3. And once I take the 3, I'm going to square that. So this 3 came from half of 6. I'm going to square the 3, and that's the number I'm going to add in here. So it's going to be 3 squared is 9. This sign is always going to be addition, because if I take half of a positive number, I get positive 3, and square it, I get positive 9. If this were negative, I'd get negative 3 times negative 3, and negative times a negative is also positive. So you're always going to add this number here. Now, this is my n. So I have added 9. Step number 3 says we're going to take whatever a is, multiply it by this n. So I've put 3 times 9 into my problem. And that means I've added 27 into this equation. I can't just add 27 because that would be changing the value. So to balance it out here, I need to subtract the 27. So now I've added 27 and subtracted 27. So I really haven't changed this equation at all. And my final step now is to rewrite this equation. So f of x equals, I put my 3 out front, and then open my parentheses. And now this is what that last line was talking about. We're going to write this as something being squared. And in the next chapter, when we talk about factoring, you'll see where all of this comes from. But for right now, I'm going to give you the shortcut of rewriting this as a perfect square. So you take the square root of x squared, which is always going to be x in these problems. We take this sign from the middle. So this sign right here, which is a plus, so I put the plus right there. And then I take the square root of 9, which is this 3 that I found in the first place. And then at the end, I have negative 9 minus 27, so that's going to be minus 36. So now I have this rewritten as a quadratic in vertex form. Because it's in vertex form, just connecting everything back, I know that my vertex is negative 3. Remember, I take the opposite of that. And negative 36. Because my A is positive, my graph would be opening up. So there's a quick sketch with my vertex being negative 3, negative 36. All right, let's look at one more example. All right, we're going to do the same thing with this equation. We're going to start out f of x equals, and again, I'm going to look at these first two terms and factor out, this time my A is just negative. So I factor out negative, you can write negative 1 if you prefer. And then I leave x squared because I've taken out the negative. When I have positive 3 divided by negative 1, that's going to leave me negative 3x. I'm going to leave that space, and I'm going to keep it plus 7 on the outside. Once again, I'm going to take half of this number, and again, it doesn't matter whether it's going to be positive or negative. This is always going to be plus. So half of 3 is 1.5. And when I take that 1.5 and square it, I get 2.25. Now I have to multiply it by the part that's out here because if I were to distribute, that's what I've really put into my equation. So I had negative 1 times 2.25, which is negative 2.25. And to balance that out, I have to now do the opposite, which is going to be plus 2.25. Right, so now I'm ready to rewrite it. Put the negative on the outside. Square root of x squared is just x. Sign from the middle, right here, is minus. Square root of this 2.25, which I have sitting right here, which is 1.5. Square it. And then on the outside, I have plus 9.25. Right, so that's now my equation rewritten into vertex form. If you have any questions, ask me in class.